In this video, we are going to see about search algorithms in artificial intelligence. There are two kinds of search algorithms. One is blind search, next one is heuristic search. What do you mean by blind search? The blind search without any information. We are searching, we are trying to reach the goal. But heuristic search with some prior information, we are trying to reach the goal. Okay, here what are the blind search? The BFS, DFS, depth limited, iterative deepening search, uniform cast search. These are the various blind search techniques in AI. Then heuristic search example, the best first search and A-star algorithm, AO-star algorithm. These are all the heuristic search algorithms. Actually, here this blind search guarantees at least one solution to the given problem, but in this heuristic search, we are trying to find the optimal solution, but may or may not be giving the solution. The important terms to know about the search algorithms, the search space, with some possible conditions and solutions we are moving. Initial state, goal state, problem space, that is what to solve. Searching strategy, search tree, these are various terms we should know about this. Then the first one is about blind first, first blind searches, breadth first search, BFS. How do you search? We are starting from the root node. Then level by level, we are searching the goal. Here first A, then we are visiting B, C again. If goal is not found, we are to visit D, E, and F, G. This is the way we are visiting in this BFS method. The next algorithm is DFS, depth first search algorithm. Here we are going to move towards A, B, D, E, completing one side. Then we are moving to the next level. For example, first we are visiting A, B, then D, H. Then we are coming back to D, I, again B, E. Like that we are visiting in this depth first search for finding the goal. Then third one is about depth limited search. In DFS, unnecessarily we had to go for searching more number of uh, nodes, even though that solution is in that second level or immediate to your root level. So instead of visiting all the nodes, we had to limit the number of search. Then how do you limit? We can set I can search only up to level 2 or level 3. Only it will search within that limit. For example, if you are going to set limit to 2, then it will go to only this up to A, B, D. If you have any levels below D, E, then this cannot be searched in this depth limiter search algorithms. For example, here the limit 1, then you are not finding any solution. Here you have to go for example, in depth limited search, we are going to set only one limit. Then even the goal may be in the next level cannot be searched properly. So we can go for using this iterative deepening method, the IDDFS method. Here we are keep on searching. First I'm going to set with the limit 1. Then I'm searching for the solution or the goal. Okay, if it is not found, then I can go for changing the limit to 3. This not possible in that previous method. So then level 3 I'm going to change this limit 3. Again I'm searching up to the level 3. So this is a way we can go for this iterative deepening method. So the drawback of DFS is even sometimes your goal may be here. Okay, your goal may be in this second. Okay, here the second. We have to go for searching 0 to 1, then 3, visiting all the nodes. We have to come back to this 2. It will take more time. Instead of wasting this, we can go for this ID DFS method. The application of this BFS, DFS, you can go for solving some problems like maze game. For example, here the start node is yes, the G is a goal state. Then here, how do you find the solution of this BFS? The BFS, you have to go for searching this S2, 1, 2, again 3. Then either it can go for 4 or 5. Here 5, 8, then 10, 12, 14, and G we can reach. Then here DFS solution, here you can go for searching S1, 2, 3. Then here you have to go for 6, then 5, 8, 9. This way we can reach the goal in this DFS solution. Take this example. Here this can be this maze game can be converted into tree. Then this way we are going to visit S1, 2, 3. Here 3 we have choice of 5 and 4. Then select 5, keep on moving. We'll find the solution. This is a solution of BFS. So we can reach the goal state in 12 steps, but it is not in DFS. So the uniform, the next level of blind search. So far we have assigned the same cost for all the nodes. But here we are going to have different cost in all the edges. So this is called uniform cost search. Then you have to find just having the minimum, the lowest cost will be the best solution. We are assuming like that. Here uniform cost search. Here we have consider this tree. Here we can start from the start node. We can go for either goal G1, G2 or G3. Okay, you can use this algorithm for finding this G1 or G2 or G3. Here for example G1, first I'm going to start from S node, start node. Then the start node is we have this A, B, C and D. Here A, B, here we have A, B and D. The C is having an arrow like this, C to S. There is no arrow between S to C. So here we have this A, S to A, B, D again, which is minimum cost 5 or 9 or 6. 5 is the minimum cost. This is A is going to be expanded. Again 3 and 9. Then which is having minimum cost 1. Then again come back 9. Now reach the goal S, A, G. This is a path for reaching this G1. Again here G2 we can go for using this path S, D, C, G2. So from this graph the better solution can be identified by finding the which is having the lowest cost. This is about uniform cost search. So this is about a summary of blind search algorithms. Here in time wise, then space wise, optimal, that means the good solution, the complete, whether you got that solution. So we can have this BFS, DFS comparison. The next one is about informed search algorithm. The informed search algorithm means with some prior information or past history, we are proceed to search that solution. There are three methods: generate and test, BFS, and ASTER algorithm. What is generate and test method? The generate and test method keep on guessing. Okay, we are trying to find the solutions. Okay, we are going to check whether this is a solution, generate the possible solutions, and test whether this is the good solution or not. This is called generate and test method. Example, can use this method in traveling salesman roll-up. The traveler needs to visit n cities. Then we should know about distance between each pair of cities. Then find the shortest. For example, if we have 80 cities, definitely the human will take millions of years to solve the problem. That's why we need to go for this AI kind of techniques to find the solution. Example here, take 4 cities A, B, C, D. Then traveling salesman he has to find that best path. Okay, here this may be A, B, C, D, A, B, D, C. Like that we have more number of solutions. Generate one solution like A, B, C, D and check the feasibility or check the minimum cost. Again generate A, B, D, C, find the solution whether this is feasible or not. So generate the solution, possible solution, test. This is called generate and test example. The next one is about best first search algorithm. There are two kinds. One is greedy best first search method and A-star algorithm we are going to see here. In this case, we are going to use the evaluation function f of n. Here, the greedy best first search, we are going to use only f of n, and A-star we are going to use g of n along with that. So here, evaluation function f of n, okay, that provides the estimation of total cost. That total cost will give you whether it's the best solution or not. Okay. So how do we implement this one? Greedy for best first search BFS algorithm. It gives only f of n here. So for example, if there is any node, then it's going to find that best path from the current node to that goal state. Sometimes this will not give you the optimal solution, so we have to go for heuristic search. The heuristic search is going to estimate the goodness of the node. It's from h of n and g of n. This will give you this f of n value. Example, A-star algorithm will give you that best solution when compared to that greedy best first search method. Here we are going to use f of n is equal to g of n plus h of n. What do you mean by g of n? It's nothing but cost from the particular node to that root node, the starting node, and h of n is nothing but the particular node to that goal state. These two will be added to make this estimated cost. Okay, so f of n is equal to g of n plus h of n is a formula of this A-star algorithm. So g of n is cost so far to reach n, and h of n is estimated cost from n to goal. F of n is estimated total cost. So if we take this example, here we have these two solutions, uh, A G star or S D G. Whether G star is a good or G is a good. How do you calculate? So we will find this path from SDG. How do you calculate? F of S function of n. Here node is a S. So F of S. So how do you calculate? Apply this formula of f of n is equal to g of n plus h of n. So here a node n is S. So f of s is equal to g of s plus h of s. Okay. Then g of s, current node to that root node. This S node itself is a root node. So here this will be 0. Then h of n, the cost is given here is 10. So f of s is equal to 10. Then calculate f of d. F of d in the sense it is g of d plus h of d. So g of d is here that node to that root node. Okay, so that will be 0 plus 3. This 3 will be added here. 0 plus 3 means 0 plus 3. It is 3, and the cost this h of d is 9. So it costs 12. Again g, how do you calculate? F of g is equal to g of g plus h of g. So how do you calculate this node to this node? 0 plus 3 plus 3. This 3 and this 3, and to itself 0. We'll get 0 plus 3 plus 3, and cost from this node to goal node is 0. So it costs C. So our total cost is f of s is s plus s d g, you'll get 28. Like that you're going to calculate for s a g star. F of s we know it is 10. F of a, how do you calculate? 0 plus 2 and 8. You'll get 10 here. And f of g star, it is 0 plus 2 plus 2, and distance from this node to that root node 0 will get 4. Total cost is 24. So here this ESA G star will give the best solution than STG. This is about A-star algorithm. Thank you.